Here we're going to look at area as probability. So the whole idea here is to use some areas to calculate various probabilities. So just the most important thing here, guys, to keep in mind, if you want to find the probability of hitting an area, let's call it area A, all we have to do is do this. The probability of getting that area A is going to be equal to the ratio of the area of that area A, okay, out of all possible areas to hit. Okay, so let's look at maybe two examples quickly. Here it says a point is chosen at random in the square shown below. So you got this square, and a point can be picked anywhere in that square. Find the probability that the point is in the shaded circular region. Each side of the square is 6 centimeters. It's labeled on there, and the radius of the circle is 3, which is also kind of obvious since the circle fits perfectly inside of that square. Even if they didn't label that as 3, you should have been able to tell that that would be 3 because it goes from center to the edge, so the whole thing would be 6. So they're giving you more information than you really needed. And they're telling you to use the value of 3.14 for pi and round the answer to nearest hundredth. So this is like my area that I want to hit, right? The circular area. So if I want to find the probability of hitting A, all I have to do is get the area of A and divide that by the total area possible. So the area of A is simple. It's just pi times radius squared. The total area is the area of the square, right? If you think about the whole possible thing, the square includes all possible areas. So pi r squared is going to be 3.14 times r squared. That's going to be 3 squared in this problem. And the area of the square is just going to be 6 times 6, or 6 squared. So we have 3.14 times 3 squared is 9. And then that'd be out of 36. So actually we can reduce this, right? Can't we go 9 into 36, 4 times? And so it turns out to be just 3.14 divided by 4. And so if I do that, 3.14 divided in 4 to the nearest hundredth, that would be 0.79. So 0.79 is that probability for this problem. Okay, let's take a look at one more. So here, a point is chosen at random in the large square shown below, right? So any point inside of this large square is going to be picked at random. Find the probability that you hit the smaller shaded square, and they give you the dimensions as you need, and round to the nearest hundredth. So this is my area A that I want, so the probability of getting A would just be the area of A over the total possible area, which if you think about it isn't that so bad. So the area of A is just going to be 6 times 6, or 6 squared. The area of the whole thing is 14 times 14, or 14 squared. So use your calculator if you want. That'd be 6 squared over 14 squared. And this calculator, I have to hit this button. Instead of be 0.18 if I round to the nearest hundredth. So that's just an idea of what area as probability looks like. Thanks for watching.